Let's paint it with the green color. That's the color coding. Fine. So what happened? Delta 1 was greater than delta 4. In our original structure, it was delta 4. Okay. So let's paint it with the green color. That's the color coding. Fine. So what happened? Delta 1 was greater than delta 4. In our original structure, it was delta 4. Okay. So here there was carbon. Right. Here there was chlorine. Fine. So that was the structure. Now how delta 1 is greater than delta 4? I have cleared it. Now you tell me that delta 2 came due to which reason? It came into the picture because the first carbon electronic cloud was attracted by fluorine. Right? And why delta 3 came? Delta 3 came due to two reasons. But the major reason is this. Delta 3 came due to the third carbon electron cloud was attracted by chlorine. Now you tell me that for the first carbon, the electron cloud will be shifted towards fluorine because it has more electronegativity than chlorine. Okay. So first carbon will be more, apparently I am talking these things. Okay. Because complete electron transfer is not happening. So first carbon will be more electronegative because it is in need of more electrons. So first carbon will be more electronegative than third carbon. Right? Because in the third carbon, its electrons were attracted by chlorine and chlorine is less powerful than fluorine. Fine. So first carbon will be more electronegative. Therefore, it will attract first carbon. It will attract electrons of second carbon more. Why? Because it is in need of more electrons. Therefore, I can say this line. So, delta 2 signifies the difference between first and second carbon. Okay. Then comes the third carbon. So third carbon is deficient of electron. It will attract electrons of second carbon. But third carbon is not as much deficient as first carbon is this, because in the third carbon the electrons are attracted by the chlorine, which is less powerful. So it will attract the electrons of second carbon, but of lesser tendency of the situation happening between first and second carbon. Okay. So this thing is delta 3. Now you can write very easily that delta 1 is greater than delta 4, it is greater than delta 2 and it is greater than delta 3. That's the question. Now comes the types of inductive effect. So discussing about the types of inductive effect, either it can be electron donating or it can be electron accepting. The thing which you need to understand here is this, that first of all it is reference dependent. It is reference dependent, and we have set a reference, that is carbon hydrogen bond, that is our reference. In a carbon chain, a group is attached and it is taking the electrons, right? It is more electronegative. So this type is electron withdrawing. More correctly, I can write here electron withdrawing also, right? So it is electron withdrawing. It is also written as -I because the electrons from the carbon are going, that is something is being less, therefore we use the sign of minus. In C, D, suppose there is something else and here it is donating the electron, means something is coming to the carbon, therefore we say it as +I and the name becomes electron donating. If I write electron donating effect, I can tell you that when bonded pair of electrons are shifted away from any atom or group with respect to carbon hydrogen bond, then atom or group shows electron donating effect. What I am saying, that when bonded pair of electrons are shifted away from any atom or group with respect to carbon hydrogen bond, then atom or group shows electron donating effect. In simple language, you can say that carbon is attracting the electrons. So this is what? This is +I, and it can happen if something negative charge thing is attached, so that negative charge thing will give its the inductive effect, or you can say it will donate its electron. Even in fact it is said that it is real +I, means it is real, it is giving its negative charge. If something alkyl is attached, alkyls also donate its electron, okay. If less electronegative atom is attached to the carbon, it is also electron donating, okay. So this was all about electron donating things. Now we will talk on the issue of electron withdrawing effect. As you know that electron withdrawing effect is represented as -I, okay. So what happens here, that when bonded pair of electrons are shifted towards any atom, okay, where they are shifting towards any atom or group with respect to carbon hydrogen bond, then the atom or group shows electron withdrawing effect. What I am saying to you, that I am not writing the full definition here, you can write that bonded pair of electrons are shifted towards any atom with respect to carbon hydrogen bond, right? Then the atom or group shows electron withdrawing, okay, electron withdrawing effect. So that is minus I. If I say to you that what groups can do this, so positive charge can do this, right? Partial positive can do this, and electronegative atoms can do this, like halogens are there, oxygen is there, nitrogen is there. Halogen can be fluorine, chlorine, bromine, iodine. So that is minus I, right? Now if I give you a question here, that is, how many of the following group or atom can act as plus I, okay? Plus I means what? It is positive inductive effect, right? Means electron donating. Your brain should start working as soon as you read the line, the very first line, okay? So what is this? What I was talking, that it is electron donating. So negative charge will do this, right? It will donate the electron, okay? So the options for you are OH, NH2, CH2 negative, CH2OH, right? A ring, CH double bond CH2, NH negative, right? And C double bond OCH3, COO minus, CH double bond NH, C triple N, that is CN, CH2 CH3, Cl, CHO, Ci3, CD3, O minus, NMe positive. Now you tell me that which compounds, or you can say which group या atom can act as plus I. So this OH, now some of you will think that this OH has electron pairs, okay? So it will donate the electron. But my dear lovely students, the thing is this, you will see the electron donating effect by the lone pair in resonance, okay? That's the concept of resonance. I know you have brilliant minds, therefore you thought this, but here these electrons will not do anything, because oxygen has a habit of attracting the electron. No matter it possesses the lone pair, but it has that thing that it can donate its lone pair electrons, but its tendency is this, it will attract the shared pair of electrons. For example, if I give you this example, suppose you are living in a hostel and you are sharing your room with roommates, okay? This is your one room, and you have your another room that is at your home, okay, and you are not sharing it with anyone. So what is your tendency, or you can say what becomes your tendency, that you are ready to give your room which is at your home to your younger sibling, to your elder sibling or to your any family member. You are agree, means you have the tendency to donate your room. But in the hostel, you don't have the tendency to donate your room to your roommate. You are not going to hand over your room to your roommate. What your tendency is this, you are living there, so you need your portion, and even you try to expand your portion. You try that your roommate will go in a corner, he or she will live there, and you will live at a bigger space. Suppose this is your tendency. So that thing is working here, that here it is not donating its lone pair. It will donate its lone pair when we will read resonance. Here what is this OH doing? That due to the electronegativity difference, it is attracting the electron. So it is not electron donating, it is electron taking, right? Electron withdrawing. So this shows minus I, it doesn't show plus I. Similarly is the case of nitrogen, that it will donate its electron pair in the resonance. Here what it is doing, it is attracting, that is minus I. Here it is a negative charge, and it is ready to give its negative charge, that is its lone pair, or you can say anion negative charge. So it is plus I. Yeah. In CH2OH, nothing is happening like this. If you see CH2 means an alkyl is there, so yeah, it will be electron donating. No, it will not be electron donating. Why? Because this oxygen is also here, and it has already attracted the lone pair, the pair electrons even from the carbon. So this carbon becomes electron attracting from here. So it is not electron donating, it is minus I. This is an alkyl group, and we know alkyl groups are electron donating. Here it is CH double bond CH2, means alkene is there. So it doesn't want to donate its electrons, right? What it wants anything to come and react with it, so that it can become saturated one. So it is again minus I, it is not plus I. In NH it is a negative charge, it can donate its electrons, right? So it is plus I. Here it is chlorine, chlorine is a halogen, it has a higher electronegativity, so it is minus I, it will just only attract the electrons, it is not going to give you electron. Here it is CHO, and you know that due to hydrogen there will become a great electronegativity difference, and it will take the electron, so it is minus I. This is a alkyl group, this is plus I. This is C, here there is a correction, it is not actually I3. Carbon cannot accommodate iodine because of molecular it will iodine is much of greater size than of carbon, so due to hindrance it cannot accommodate. It was actually, I wanted to write tritium, that is hydrogen's isotope. So it is also plus I in nature, right? Because it is tritium is just the substitution of hydrogen, it is same as that of hydrogen, and we know that if it was CH3, CH3 is an alkyl group, so CT3 is also an alkyl group. Here again due to the oxygen it is minus I, here COO minus is there, right? So oxygen is now full up of electron. Now it is ready to give its electrons due to its negative charge, that is real induction. So it is plus I here, right? Here it is CH double bond NH, it is again minus I due to nitrogen. Here again due to nitrogen it is minus I. Here it is CH2 CH3, it is alkyl group. Here it is plus I. Now we talk about CD3. We know that it is the isotope of hydrogen, so it is just like CH3 and it is plus I. Here it is O minus, there is a negative charge on oxygen, therefore due to its negative charge it is plus I. It is ready to donate its electrons, or you can say it is ready to not to take the electrons from the carbon. Here it is positive charge, positive charge will attract the electrons, okay, opposite attracts. So it is minus I, it is not plus I. Now we will understand about isotopic effect. So what is this isotopic effect? Hydrogen D and T, These three are the isotopes, or you can say D and T are the isotopes of H, that is hydrogen. You know that C, H, C, D and C, T. This is the bond length order of carbon and hydrogen isotopes, which I think that you have read already in hydrogen. But if you have not read it, so let me tell you that the mass order is this, that is tritium, then deuterium, then hydrogen. Mass order is this. So due to higher mass, it cannot vibrate and it remains close to the carbon. Therefore bond length decreases. So this is the reason. Now you know that more bond length means less electron density. Electron will have to spread just like this. Therefore bond length is inversely proportional to what? Electron density. Therefore I can write the order of electron density as C, T, C, D, C, H. You know that if I want to donate the electrons, there must be electron density at the bond, right? So plus I effect is CT3, then CD3, then CH3. I hope this order is clear to you. Similarly, if I talk about the inductive effects of 3 degree, 2 degree and 1 degree carbon, so
with one-to-one mentoring, chemistry becomes logical and real improvement begins.